Haven't seen anybody log on yet. All right. People starting to pick up. We're going to start right where we left off. Hello, hello. All right, we're getting more and more people signing on. All right. And last time we averaged about 12 views. So I'm going to give everybody a moment. Okay. I'm going to send out a message to see who else we can recruit. I got 5 of you guys on here. Good. All right. And again, I can put up the conference call number because I know that we had 1 or 2 people that had a question on this last problem that we had left off on. So we're doing one-step algebraic equations with fractions. All right. So, as we're still getting more people on here, go ahead and tell me what you think the solution is to this problem. Again, I prefer that you guys use a text message feature. If not, if you have questions, let me know in the live chat that you have a question. So again, while we're waiting for everybody to join, please let me know what you believe the value of the variable W is. What is the answer? Okay, still haven't heard. So I guess I'm glad that I see Mariana's here, Brandy's here, Corolla's here, Alma's here, Diane. So now that we're back, please tell me what the solution to this is. All right, like I said, free to send me a message. Feel free to do the live chat. All right, perfect. Happy to see you here, Andre. All right, outstanding. And I appreciate the fact that some of you are reaching out to the Google number that I provided. Just responding to some of you. Okay. All right. Okay. There's one more person that we are waiting on. All right. So when we're looking at this one-step equation, there's a couple of things that we can do. And I believe that a lot of you probably use algebraic thinking and inverse operations, meaning that you were to look at this and you were to say, okay, well, what can I subtract 8/15 by to get 11/15? So automatically, I know that some of you would go to 19/15 because that subtracted by 8/15 gives you 11/15, right? So to some of you, this is fairly obvious, okay? But we're going to talk about some other methods because we're not always going to have common denominators, okay? So something else that we can do, if you want to know how we got there, because it wasn't obvious, it was not something that is part of your background knowledge or schema, what we could do is, what we have to do is isolate the variable, right? So how do we get this variable by itself? We have to get rid of this 8/15. And because they're subtracting 8/15, I need to add 8/15. That's going to cancel out on this side. And because I do it to one side, I have to do it to the other side. So when I add 8/15 here, what am I going to get? 19/15. Question so far? Again, so if there are no questions, so that I know everybody's here participating and that they're awake, please let me know in the live chat. No questions. If you have a question, respond with yes and the question. All right. Okay. So we can use the conference call feature if we have questions at this point. so that we can walk it through together. And I will be adding the conference call. So I'm going to put the number up and feel free to join. It I like it because it allows up to, I want to say, like 50 people to be on the call. And I like for the people that call in to really walk us through how they would solve this problem. So I'm going to erase this and I'm going to add in the conference call number. Okay. So the conference call number 718-362-6120. The pin is 1618044. And I will also send it through the live chat as well. It's also found on the website. Got a question online. And again, I'm going to call into the conference call now, and I'm still going to be typing up the number. So bear with me a moment if you try to call in and I have not responded yet.
Please enter your PIN number. Thank you. Joining the conference now.
All right. So let's see how we would walk through this together. I know I got a few people on the conference call. I'm going to mute this. Okay. So, Lillian, go ahead and walk us through the first thing we would need to do to solve this problem. So go ahead and walk us through, Lillian, what we would need to do to solve this problem.
Trying to explain to me, she understands where you're at, but I still don't. So you kind of gotta walk me through it again.
Okay. So
thank you.
No worries. So what is always the first goal when we have a variable? We have a letter that's representing an unknown number. What is the ultimate goal that we want out of this equation? Just like, remember what we did last time, right? When we have that letter and it represents the unknown, we need to find out what that letter equals. Remember how we need to find out what that letter equals? So
by adding the equation.
Say it again.
By adding the equation?
Correct. So we need to get the equation so that the variable or the letter is on one side of the equal sign and every other value is on the other side. That way we know what the variable equals. Does that make sense so far?
Yes.
Okay. So what do I need to do so I can get this W by itself so I can figure out what it equals? What do I need to do?
Move it over the equal sign.
What's that?
Move it over the equal sign.
Well, I can't move it yet because I still have this minus 8/15. So what do I need to do with this minus 8/15?
Subtract it from the 11/15.
So
to a positive. Oh, add it to the 11.
There we go. So we're going to add it. So we're going to add the 8/15 here. And when we add it, this is called an inverse operation. So when we add it, what is it doing here? What is it doing
Taking it away.
Taking it away. Now cancel.
It out.
There you go. Now what do I have to do?
Add it to the 11/15.
Add it to the 11/15. And what is that going to give me?
19 over 15.
And what's left on the other side of the equal sign?
The W.
So what does W equal?
19 over 15.
The end. You got it. Questions about that?
You just taught my daughter how to do it.
That's all right. It's algebraic thinking. So there's going to be concepts that even students that are not necessarily in high school or college are going to identify with because they're doing similar things now in like first and second grade where they're going to say there's 3 fishes over here, an unknown amount of fish here, but altogether there's like 10 fish. And then they have to use algebra to solve it. So you're in good company.
Yeah, she's gonna help me tutor me.
Yeah. So let's do one step, and then we're going to move on to two-step multiplication or two-step equations with decimals and fractions. All right, so let's do one more. And if you did not get a chance to work on the two-step equations, I know I sent the link out. Definitely let me know if you want more practice, even after we finish with the lesson. There will be times where the day might end up being mostly math or mostly reading. And I try to do that when we need it so that we keep the integrity of the lesson. So
instead of doing the equations, because I'm just not there yet, I just was rewatching the video where you were, I just rewatched the last video to try to catch up or try to get where everybody else is at, so I'm not holding everybody back. You know what I mean?
Yeah, no, and that's okay. In fact, if you ever have a question and you speak up, I would encourage the other students to help out because if they can walk you through it, that means that they have mastered it. So that's the benefit of them being able to do that.
Don't make it sound like you're wrong. Your brain is better than one. Your brain will work as a two. And we'll just cut some of my brain on.
Okay, so it's like I'm just checking to see if anybody's sending me any questions. Try some more. Okay, so let's put up another one-step algebraic equation with fractions. And again, send me your answers through text so that we try not to give it away. All right, so go ahead and solve for A.
So, what are you going to do? Look on the first, right? And then over here. And since you canceled it out, this will not be my subtraction. Okay, so but we can't subtract it straight across. So which one should I use?
times don't really have a lot of control over it. So I would recommend you guys joining the conference call if it does go out.
So wait, okay, so we're here. 90 times 7 things denominator. So if you times this by 3, this would be by 3, this by 4, this by 4, now you have 12. Oh, well, I totally understood that. You cancel the.
All right, you want to walk us through it, Lillian?
No, I'm not even. No, I'm asking a question. So if you cancel, you cancel the 5/4 out and you move it in front of the 1/3 and you subtract.
Well, if we moved it this way, then we would have the variable and all the numbers on one side of the equal sign. And we really don't want to do that. The goal is to try to get this variable, this letter that represents a number we don't know. The goal is to try to get this by itself. So what we really want to do is move the 1/3 to the other side.
Move the 1/3 on the other side of the 5/4?
Correct.
Okay.
So now the question becomes, so we know we have to do that. Now, is 1/3, can I subtract that by 5/4? Are those fractions the same? Are they equivalent?
No.
So what do I need to do first?
That's where I'm stuck at.
Okay, so let's rewrite that. So we have 1/3. All right, what we really have here is 5/4 subtracted by 1/3. So do you remember the steps I gave you? The butterfly method, the crisscross applesauce moves, the algorithm? If we need to make these the same. Okay, so what do we do?
So then that would turn it into a multiplication, right?
Yes. So what would be the first step?
You flip the 1/3.
Well, that's when we're multiplying. But here we're subtracting. So we do need to multiply some numbers so we can have the denominators be the same, right? So here I have
times 4.
Yes.
4 times 3?
Correct. So I do 4 times 3.
Okay.
That means that my new denominator for both fractions is going to be 12, right?
12.
Now what do I need to do?
Times the top as well, right?
Correct. So I'm going to take 4. I'm going to take 3
Multiply the top
and multiply it by 5. Right? I'm kind of creating a butterfly here. So that's going to give me 15. Right? Now, because I did it on one side, I had to do it to the
other side.
There you go.
Okay. So then 3, that would be 12. And then, so would be 5/12 or subtract 3/12?
15/12 subtracted by 4/12s, right?
4/12. Oops, sorry.
No, it's okay.
4/12. Okay.
If it makes more sense, now that we made them equivalent, one of the things you can do, because I know that this is a lot of work and you try to keep track of it, what I would do to keep it simple, now I know what both fractions are when they're equivalent, I would rewrite them as their equivalent fractions. So I know that this is really 4/12. And what is 5/4 really as an equivalent fraction?
For me, the way it ended right there would be the easiest.
Okay, so either way. So you could rewrite it. You could work it out from here. So if the fact that I am subtracting 15/12 by 4/12, that lets me know that I already subtracted the 4/12 here. So that's by itself. All I have left over now is the A. And the A is going to equal whatever this equals.
So the A equals the 11/12.
Exactly.
Answer to, okay.
And that's it.
This is replacing the equation with that. Oh, okay. Okay, thank you. Thank
Thanks.
you.
Talking to me? Oh, yeah. Very welcome.
Can we can we try one more?
Absolutely.
Yeah, another one like similar to this one.
Yeah, absolutely. All right. So yeah, I'm gonna make sure we don't use one that has equivalent fractions.
This is the part that I'm gonna have to practice. The quick class. Remember that. Do that. I would help if I practice multiplication. So it helps me to practice.
All right. So 11/6 equals n plus 7/9.
Oh, we have to go over here, right? Yeah. Okay, give me a second on this one.
Everybody else got a brand new problem.
So with this next problem, you find a common. Is it a common denominator, or a number that will go into 3 and 6, 6 and 9, or 6, 9? Sorry.
Yeah, there's a couple of ways to do this. So I would stick with whatever is going to be easiest for you to use during the test. If you know your greatest common factors, then you know that you'd be able to figure out what number both 9 and 6 can evenly divide into. So that's one method. If you don't know your greatest common factors, I would recommend just multiplying the denominators together. Even if it gives you a bigger number, you're still going to be able to solve the problem.
It down?
Yeah.
Okay. So multiply, right? Yeah. And then you multiply the top as well?
What's that?
Oh, no, crisscross. Okay. Okay. No. Okay. Answer my own question.
No, it's all right.
So then do your butterflies. So then since you times this side will be times 6. And this side will be times 9. Wait, okay, I don't understand. Okay, so it wouldn't be times 3? No, because you're not doing it that way. So that would be 6 times 7, 54, right? It's your thing. From writing thing. So now, 7 times 9 is what? 7 times 9 is 63. Minus 11 times 6 is 66 equals 10. So now you have 66, 54 minus 66 over 54. Or 66. So then 3 over 54 equals 10. Oh. So it's 3 over 54? Or you guys still break that down?
So I know I had you in the previous class. What was the rule to know if a number can be divided by 3?
I don't know.
If you add all the numbers in a multi-digit number, right? And a number that has multiple digits, if you add them together and that number can be divided by 3, then the whole number can be divided by 3. So 54 can be divided by 3 because 5 plus 4 is 9, and 9 can be divided by 3. That means that 54 can be divided by 3.
So it's 3. Wait, 3 today? 18? Yeah.
Okay, so I got people. Okay, let's walk through this together because I got a few people that have given me some responses, and then I got some people that are still working. So I think we would benefit from all of us starting it together. So let's go and look at this problem. So what's the first thing we should do? Same thing as the last problem. What's the first thing we should do?
You gotta move the 16.
Yep.
Over. Yeah.
We have to try to get this variable by itself. Okay, good. So what should I do to get this variable by itself?
7 over. Oh, move the 7 9 over by the 11 over 6.
Now, are these two fractions the same?
Yeah. No. Yes. Cancel.
We have to cancel it out. Well, first thing we have to do is make them equivalent. Then we can cancel it out, right? So how can I make these two fractions equivalent?
By multiplying the bottom.
Good. So let's rewrite these here. Yep. 11 over 6, right? And then 7 over 9. We're going to use, so if they ask you what method, they won't, but this is like for your own personal development. What we're doing right now is an algorithm. It's called the standard algorithm. We're just following steps, right? So we're not using a model or anything like that. Okay, so 11 over 6, we're trying to make it equivalent to 7 over 9. So you said we're going to cross multiply. So what are the first two things we're going to multiply? Let me write this up a little bit higher so I have more space. What are the, go ahead. Go ahead. Go ahead. What are we going to do? Huh? What's that?
Multiply 7 and 9.
Good. So we're going to multiply 7 and 9. I'm sorry, 6 and 9. What's that going to give us? 54. So we know our denominator now is going to be 54.
1,000 plus 1,000 equals 2,000. Yep.
Now what?
And then
Good. So
multiply. You multiply 6. Wait, yeah, 6 and 7 and 11 and 9.
Correct. So here I'm going to do 9 times 11, and what is that going to give me?
99. Wait, 9 times 1, right?
Yep. So that now gives me 99. Now what?
And then so that would be 99 over 54 on one side, right?
Yep.
99 over 54 on one side. And then you multiply 6 by 7 on the other side.
Correct. And what's that going to give me?
And that's 42? I don't know what.
Yep. That's going to be 42.
42. Okay.
Now what do we have to do? Correct. So that's going to be 99 over 54 subtracted by 42 over 54. What's that going to give me?
Wait, 99. Sorry, oh, 57. 57 over 44. 54. 57 over 54. That's a lot of numbers.
Mm-hmm. Now, is there any number that can go into both 57 and 54?
One. Evenly, no.
Well, remember that trick I taught you?
With the, let's see. So you divide the bottom into the top?
Well, that's to change it into a mixed number. But this fraction can actually be smaller. This fraction can actually be made smaller because both the numerator and the denominator can be divided by the same number. And there's a little trick I gave you before.
Is it with 3?
Correct. So what is 57 divided by 3?
57 divided by 3 is 19.
There you go. Now, keep in mind that if you take the test and you're using a calculator, your numbers could be bigger. I know that there's a couple of versions of tests that allow you to use a calculator. That's my opinion. One of the drawbacks is that they can give you numbers that are going to be harder to work with because you have the calculator. So you can play around and figure out, if you don't know it by looking at it, how to simplify it. Using it by doing the problems by hand, the numbers are going to be smaller. That's just a heads up. So 57 can be divided by 3. Can 54 be divided by 3?
Yes.
Why?
Well, because it went into 57.
Huh? Remember that rule I taught you? What was the rule?
Yeah, so 3. Okay, this one takes me a second. 3 goes into 54. 1. I'm sorry.
No, it's all right. You're perfectly fine. Everyone on the live chat is following along. They've been sending in comments. I love the fact that you're brave enough to let us walk with us and do this. Walk through this with us.
Okay, so did 3 goes into 54 18 times?
And how do you know that 54 can be divided by 3?
Well, because I just kept dividing and subtracting.
Well, remember the rule I gave you a few minutes ago? If you add these numbers together and whatever number that is can be divided by 3, then this number can be divided by 3. So 5 plus 7 is 12. Can 12 be divided by 3? Yes. So that means this whole number can be divided by 3. 5 plus 4 is 9. Can 9 be divided by 3? Yes. That means that this whole thing can be divided by 3 evenly. Just a little trick from last time.
Wow. Yeah, I must not have been paying that.
Oh, it's okay. It's okay. It's been a week or so. I know that, especially with everything going on. Yeah. But those are little tricks. Okay. Like if it ends in 0, it could be divided by 5. If it's an even number, it could be divided by 2. Right? So those are little tricks when you get to fractions to know if you can simplify it.
Okay. I'll keep those in mind. I'll memorize those.
Yes. Good way to look at it. All right. And we got about 19 minutes left. So let me know in the live chat and if you're on the conference call, do we want to move on to two-step equations? Two-step equations.
Thank you. I appreciate you.
Oh, you're very welcome. I love the fact that you're participating, and there's a lot of people on the live chat that are benefiting from you also speaking up.
proper section? I don't. It's supposed to.
I'm just waiting for everybody to respond.
I just want you to know I feel like my brain just grew.
No, you know what? I think it's great that you participate. Everybody really benefits from seeing you and talk it out
Struggle.
and walking through it with you. It's really beneficial for everybody, and I'm glad that you called because it helps out the people that maybe are a little too shy to call or are scared. So,
That's normally me.
uh
Oh, yeah, that worked great. That was my
okay. So I'm gonna put one up. It's gonna be a little challenging, but I think it'll be a good way to test what we are comfortable with. I don't see anybody having a question. Yes, 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 yes. Okay. So it's going to look a little intimidating, but don't be scared. Stick with the fundamentals, right? Stick with isolating the variable. There's more than one way to get the answer. So, so give everybody some time to work on that. Okay. See, some people are saying they're stuck. All right. So let's work through this one together. All right. So let's walk. Okay. So I know a lot of people are saying that they ended up getting one and they weren't really sure how that would work. Okay. So I will show you how to do that. I just want to make sure there's no one else with a question. Okay. So let's start off with the first thing. And feel free, Lillian. I know that got you on the line and we're doing this all together. So let's start off. Where do you think we would begin on this problem?
Okay, so see, this is where you threw me for a loop because I was waiting, I'm waiting for you to explain it because I don't.
Yeah. Well, what is the first thing we're always trying to do?
Find the variable.
Correct. So we need to get this variable, the z, by itself. Right? So it's 15 times z minus 1/5 is going to give me 12, right? So let's get rid of this 15. If they're multiplying by 15, what do we need to do?
Wait, what? Yeah. What?
See how they're multiplying by 15 here? We're trying to get the z by itself, right? So this is called using mental math, friendly numbers, right? So if they're multiplying by 15 here, and I want to get rid of everything except for the z on this side, what should I do with this 15?
Times it to the z to the 1/5.
Well, they're already multiplying it. What can I do if I want to get rid of that 15?
Just erase it.
No, I can't just erase it. If they're multiplying by 15 and I want to cancel out the 15, what do I need to do with that 15?
Is it 15 over 1?
It is. So what I could do, since they're multiplying the 15 here, I can divide by 15. And if I do it on one side,
Do it to the other.
you got to do it to the other side, right? And there's multiple ways to solve this. We're looking at the fastest, most efficient way to do this. So I don't even know how many different ways you can go about this. But we're concerned with trying to get the variable by itself. It's easiest to divide by 15, right? So I divided by 15, got rid of the 15 here. I had to divide by 15 on this side, right? So now I have 12, 15 equals, I'm going to use a different color so it's still easy to see, z minus 1/5. So I'm getting closer to getting the z, that variable, by itself. So what's the next step going to be?
I'm spinning on the computer. Yeah, I just missed the big part of that. Okay, so he divided 15 to get z by itself, right? So you can do this side, you can do this side. So then 15 and 15 equal 1, you cancel each other out. So now you're just left with z minus 1/5. Okay. Now, and now just going straight across.
Okay. So what should my next step here be?
Make the denominator same.
Correct. Right. And there's a couple of different ways that I could do that. What would be the easiest way? Huh?
So 12 over 15, and then that would be 1. So multiply the bottom. Or no, divide.
You could. You can make it that way. Also, what do we know about fives? I brought up this rule about 2 minutes ago. What do we know about fives?
Five, five can go into 15 3 times.
Correct. So
So
I could either make this one out of 15, or what about this fraction? Can I make it smaller? Can I simplify it? There's a lot of things I can do here. So we're going to talk about a couple different things. So now that I'm here, I could multiply them together. That's going to give me a bigger number. That will work. I'm just going to have to make it smaller on the back end. That's one way. Yes, I could do that. But I also know that
the 3 into the 12 and the 3 into the 15 to make that smaller.
correct. Divided by 3. Divided by 3. You're very smart, Lily. Very smart. What's that going to make this fraction now?
Smaller. Okay, so 3, 6, 9, 12. So that's 4/3, right?
Yeah.
Okay.
So 4, because 12 divided by 3 is 4. 15 divided by 3 is what?
3, 6, 5. Oh, 5/5.
Yep.
Yeah.
So now we have 4/5 equals z minus 1/5. So what do I have to do now? I'm going to erase some of this so I have more space.
Subtract the. No, wait. Now you have to move the 1/5 over in front of the 4/5, correct?
Correct. So let's rewrite this. I'm just going to rewrite it so we have more space to work this out. Okay. So what did you say we have to do?
So you move the 1 in front of the 4/5 and then yes, you add it, which would be 5/5, which would be a whole. Is that
Correct.
right?
So we're going to add 1/5 here, which is going to cancel out the 1/5.
Uh-huh.
We're going to do the same thing on the other side. 4/5 plus 1/5 equals 1 whole. And what do we have left over?
Oh, yeah, equals 1.
Now, I saw in the live chat people were saying, I don't understand how that would be the answer. So let's go ahead and plug that back in. All right. So let's go ahead and rewrite the problem. We know the answer is 1. So 12 equals 15 z minus 1/5. Well, we know z is actually 1, right? So let's rewrite this. It's actually going to be 12 equals 15, 1 minus 1/5. So let's work out what's in the parentheses, right? And there's a lot of ways we can look at it, right? So I'm going to give you a couple of ways, mostly because this is going to be important. This is the whole, right?
That's why I keep doing this out of way.
This is a whole. What can I add to 1/5 so I can get a whole? We're using algebraic thinking, right? What can I add to 1/5 so it gives me a whole?
A 5.
Okay. Well, if we add a 5, that's going to give us 5 and 1/5. That's too much. We just want a whole. So there's one way you could look at it. You could say, well, I know that if I were to take 4/5 and add it to 1/5, what would I get? Yes, we can. We can do the problem like this. No problem. Yeah. So we know that 4/5 plus 1/5 gives you 5/5. And what is 5/5? What does 5/5 really mean?
1.
1.
1 whole.
1 whole, right? So if that is 1 whole, then what we're really saying here is that we have 15 multiplied by 4/5, right? Because 1 subtracted by 1/5 is 4/5. That's one way I can get 4/5. Another way I can get 4/5 is by doing the same thing we've done before. Every whole number is always over 1. So we have 1 over 1 subtracted by 1 over 5, right? So crisscross applesauce time. Crisscross, the butterfly method, whatever you want to call it. Multiply these across. I get 5, right? 5. Up here, I now get 5. Multiply across, I now get 1. What is 5/5 minus 1/5? Lillian. What is 5/5 minus 1/5? That is outstanding. So somebody put in the live chat that they believe it's easier to convert this all to decimals. That is exactly what the purpose of this class is. It might be easier for you to look at it as decimals. It might be easier to look at it as a fraction. There's no limit to how these can be solved. You want to use as many tools as you have available to you. In fact, if you like converting the numbers, I would recommend when you test, do not try to take the test with the calculator. Probably would be easier by hand. That's just my personal opinion, given the fact that you want to manipulate the numbers. But yes, whole numbers are fractions, and fractions are also decimals, and they're interchangeably all the same thing. Okay? Whatever's going to be easiest for you. We call that making friendly numbers. So, all right, are you still with us, Lillian? Hello?
I am.
Okay, so
I am.
yeah, what? No worries. What is 5/5 minus 1/5?
Oh, 5/5 minus, wait, 5/5 minus 1/5 is 4/5.
Correct.
Correct?
Correct.
I had to write it down. Okay.
So you understand? Everybody understands how we got here. This may look intimidating, like, oh man, how are we going to do that? Remember, every whole number is always over 1. Since the numbers are next to each other, we have to multiply. How do we multiply fractions?
By finding, wait, straight across.
Straight across. So,
yeah.
What is 15 times 4?
Oh,
What is it?
Is it 60?
Yep. 1 times 5.
5.
So, what is 60 divided by 5?
See, 12.
And that's how we know our answer is right.
Nice.
Good. We got everybody kind of keeping up. All right. So let's see if we can at least do one more. I know that we're kind of going over the normal scheduled time. Claudia, are you still with us? Oh yeah, looks like she dropped off. Okay.
Sorry, I kind of hogged it all up.
No, it's okay. Claudia's like essentially my boss. I just wanted to make sure that she was still here and see if she was okay with me going longer. I want to make sure everybody learns, so I'll go as long as we need to. Okay. So let's look at another problem. It's going to be very similar. Multiple steps.
I'll find you guys.
5/4 equals -4c plus 1/4. I'll give you guys some time to work that out.
Yeah. Negative 4. Yeah. Okay, let's read it. I think you said if it's by itself, it's always over 1. That's why you're able to put 15 and do it on each side.
Yeah, I'm not sure if you're talking to me or.
Oh.
No worries.
Sorry.
No worries. Give everybody a few more minutes. Somebody asked if it's okay. No, I purposely sent out the videos for everybody to get comfortable with. So that's actually called a flipped classroom. So that's why I sent it to you so that you're getting it from the video. You're getting that you're getting those methods, which is a mix of a model using models and the standard algorithm. Then you also get it from me. So whatever is going to make it easiest for you, whatever you vibe with is fine because the ultimate goal is to pass. I am also the reading teacher. So today, because we're trying to hit multiple things, we just stuck with math, but I am also the reading teacher. Tomorrow, we're just going to hit reading. That's just kind of the way the class flows sometimes, because in a 3 hour period, covering both is not always going to be realistic. Let's go ahead and hop into this so I can let you guys have your Tuesday back. Okay. So, what is the very first step that I'm going to take here? What's my goal? Same goal that I always have. What's the goal? And Lillian, you can answer this since you're on the conference call. What's my very first goal? Okay. All right, I'm going to continue on. So I want to get the C by itself. So I'm going to subtract 1/4. So I can get rid of this 1/4. If I do it on this side, I need to do it to the other side. So 5/4 subtracted by 1/4 is going to give me 4/4. All right. 4/4 is a whole or 1. I can leave it as 4/4. I personally think 1 is a friendlier number right now than 4/4, but it's the same thing. Okay. So it's going to be 1. Notice I still have this negative 4c. So what do I need to do here so I can get the c by itself? Good. Someone says we need to get the letter or the variable by itself. I always try to use the math terms so that when you see it on the test, you're not confused by that. It's okay if you think of it as a letter, but understand in math terms as a variable. Good. Somebody said to divide, right? So we're going to divide by -4 because the opposite of multiplying by -4 is dividing by -4. So that's going to cancel out. So I'm going to get equals C. So 1 divided by -4 means that C equals 1 divided by -4, otherwise known as -1/4.
Couple minutes, okay? I didn't get that because I need to learn. Can you tell me what the rules are for, like, multiplying it straight across?
So anytime that you're multiplying a fraction, you multiply straight across. If you are subtracting fractions or adding fractions and they're not the same fraction, like they don't have the same bottom number, the denominator, that's when we multiply the denominators and the numerators and all that stuff together.
Okay.
Make sense?
Yes.
Questions here before we plug it back in to check it. Yeah.
So a negative and a negative is a positive? Yeah. Yes.
Correct. When we're multiplying or when we are dividing.
So multiplying and dividing, negative and negative equals a positive.
Got it. Okay, sorry, excuse me for 1 sec. Hello?
Hello?
Hello, who's this?
Hello, hi, this is Carmelo on behalf of Amerishare Financial.
Yeah, I already told you guys I'm not interested, man. This is the second time you guys have called.
Okay. How nice is it, sir?